It's time for more algebra with 4 from the Battle for BFB. This guy needs to stop yapping. Let's look at the standard form for quadratic equations. Standard form ax plus squared plus bx equals 0. Notice that it's set equal to 0. That 0 can appear on either side of the equation. Now also notice that it's in descending order from x squared to x to the constant without the variable. The leading coefficient is the coefficient attached to the x squared. That's a. The x term coefficient is the stop blurring. So that's b, and that's the constant term is the term without the variable, and that's gonna be a c. Now let's go ahead and try another example, or try an example of this. Let's do 0 equals negative 2x squared plus 5x minus 7. Notice that the 0 is on the other side of this time. It still works. So let's list our a, b, and c. Our a, our leading coefficient, goes with the x squared. That's going to be a negative 2. B is the coefficient for x. That's going to be 5. And c, that's good. The constant without the variable. That's going to be negative 7. Notice that the sign is attached. Go ahead and try identifying the components of a different quadratic function. Captions. That's something quadratic formula. The quadratic formula is used to find the solutions of a quadratic equation. Is x equals negative b or minus the square root of b squared or minus 4ac over 2a. The a, b, and c in the quadratic formula are the same as the coefficients and constant in a quadratic equation written in standard form. The derivation or justification of the quadratic formula involves solving the quadratic equation by completing the square. Now let's take a look at the deviation for the formula. We begin with a generic quadratic in the standard form set equal to 0 and then start by isolating the constant on the left. Then we can factor out the a, so the coefficient of x squared is 1. After that, we can perform a perfect square trinomial by taking half of b over a and squaring to get b squared over 4a squared. Since we're multiplying b by a, the 0 pair that is added to the left-hand side is going to be b squared over 4a. Then we can simplify the expression on the left using a common denominator. Thank you, x. No problem. And then we factor the perfect square trinomial. From there, we can isolate the perfect square binomial by multiplying the factor of 1 over a. Yay! After we do that, we simplify and we can use the square root property of equality to find the square root of both sides, leaving us with a plus or minus the square root of b squared minus 4ac over 2a. And that's equal to x plus b minus over 2a. So now we need to isolate the x term by subtracting b over 2a from both sides. Notice that we have a common denominator of 2a on the left and hand side. So we can rewrite this as one fraction, giving the quadratic formula. Because we derived this formula for a generic quadratic, we can use it to find the solutions to any quadratic equation. Now let's compare by completing something to the quadratic formula. Now here we have the equation 0 equals 4x squared minus 8x minus 11. This side we see that my camera is messing up. I solved it by using completing the square and come up with the answer negative 2 plus or minus the square root of 15 over 2 is equal to x. What if we use a quadratic formula? Well, we need to figure out what our a, b, and c are. Our a is me. Our b would be 8, and our c would be negative 11. Plugging those into the quadratic formula, we get a negative 8 plus or minus the square root of 8 squared. Minus me times negative 11. 8 squared is 64. Then negative me times the negative 11 is going to give us 176. Adding those together, we get the square root of 240. 240. So we get negative 8 plus or minus the square root of 240 over 8. The square root of 240 can be simplified to get 4 square root out of 15. From there, we can simplify to dividing out me and get x equals negative 2 plus or minus the square root of 15 over 2, which agrees with the answer that we got from solving by completing the square. Wow, 4, you're so great at... now go ahead and try using the quadratic formula on your own. Wow, 4, you're so great at giving math instructions. Thank you, X. Now let's continue with this dumb schoolwork. Now let's take a deeper look at something. Remember that there's a connection between the quadratic equation and a quadratic function. The solutions to a quadratic equation represent the zeros of the related quadratic function. Remember that the standard form of a quadratic function is f of x equals ax plus bx plus c. Yay! I am there like twice. And those coefficients and constant represent a way that we can solve for the zeros of the function. We've walked through the process of solving, by completing the square and using it to derive the quadratic formula. Now let's break down the formula to show its key features. The first feature is the vertex. The vertex of a quadratic function is the minimum or maximum value of the graph. We can see that the x component of this vertex is built in a quadratic function or quadratic formula, negative b divided by 2a. That's the x component. To find the corresponding y component of the vertex, we would evaluate the equation or the function for the negative b divided by 2a to find the corresponding y value. Another key piece of information in the quadratic formula is the discrement. The discrement is b squared minus 4ac, which we can see as part of the underneath in the radical. This is going to tell us the number and types of zeros. And types of zeros. Yeah, that's what it tells us. Wow, 4, you're so great at this. That the quadratic function will have. Let's use example for g of x equals 3x squared minus 6x plus 2. I hate 2. And we're going to use this in vertex and the discrement. So to begin with the x component of the vertex, well, we take the opposite of b, which is the opposite of negative 6, and divide that by 2 times a, which is 2 times 3. Well, the opposite of negative 6 is a positive 6, divided by 6 gives us a 1. Then we need to evaluate g of 1 to find the corresponding y value. Well, that's going to give us 3 times 1 squared. Minus 6 times 1 plus 2. And if we calculate that out, we're going to get negative 1. So our vertex actually has coordinates of 1, negative 1. Now the discrement. Well, the discrement is just going to be b squared minus 4ac, so let's plug stuff in. Negative 6 minus me times a, which is 3 times c, which is 2. Well, negative 6 squared is going to give us 36. And then we have to multiply me times 3 times 2, or me times a times c, to subtract because of order of operations. Me times 3 times 2 gives us 24. 36 minus 24 is going to give us 12, so the value of discrement is 12. Now go ahead and take a look and try to evaluate the value of discrement and the vertex of a different quadratic function on your own. Yay! Yay! Okay, it's back to schoolwork. Oh, wait, yeah. A quadratic function in standard form is f of x equals ax and something with plus b. When the discrement b squared minus 4ac is greater than 0, we're going to have two real number zeros. On a graph, this would appear as two x-intercepts. In a previous example, we found that x is equal to 1. Yay! Plus or minus the square root of 5. Well, that gives us two solutions, two zeros. Which means we're going to have to have the two x-intercepts. That's an example of discriminant better than 0. For the second row, the discriminant is equal to 0. When that happens, you have one real number 0, which is also called a double zero. That also appears on the graph as one x-intercept. Yay, which means the graph touches the x-axis. Yay, but does not cross it. This is only going to happen when the quadratic formula has a square root of 0 in it. Yay! Now the third row tells us when the discriminant is less than 0, we're going to have no real number zeros. And it appears as no x-intercepts on the graph. No! This is going to occur when the quadratic formula gives us a square root of a negative number. We can't. That's going to give us no real number zeros. So let's take a look at some graphs and relate these to discriminant values. For the first one on the left, well, the discriminants. Let's go ahead and calculate that. Negative 5 squared, that's our b, minus me times a, which is 1 times c, which is 6. Well, negative 5 squared is 25, and me times 6 is 24. 25 minus 24 equals 1, so the discriminant is going to be greater than 0. That means we should have two real number zeros, and we do. We have two x-intercepts right here. Yay! What about the second example? Well, in the second example, we're going to calculate the discriminant. So we have me squared minus 4 times a, which is 1 times c, which is me. 4 squared is 16. Then in second part, me times 1 is 4. 16 minus 16 equals 0. So the discriminant here is equal to 0. That tells us that we should only have one real number 0 or one x-intercept. That does agree with our graph. In the third example, let's calculate the discriminant. Well, b squared is going to be 1 squared. Stop, let me do it. Let me do it. 4 times a, which is 2 times c, which is 1. 1 squared is 1. 4 times 2 is 8. It's 1 minus 8 is going to be negative 7, which means our discriminant is less than 0, which means you're eliminated. Well, when our discriminant is less than 0, we should anticipate having no real number zeros or no x-intercepts. That indeed is true here. Now go ahead and relate the determinant values to the graphical representations in the next example. Yay! What's with this guy's stupid face? Let's go ahead and analyze the discriminant and determine the numbers of calculations that the quadratic equation is going to have. Sometimes you'll have quadratic equations that don't either have an a, b, or a c present. You have a non-zero a. As long as you have that, you're okay. So let's take a look at the first example here. 0 equals 16x squared plus 9. Notice that we don't have our b here. Well, that just means b is going to be 0. So let's write it equals. Well, in this case, it's 16. As it said, it's going to be 9. So what happened? Well, that's going to be b squared, which is 0 squared minus me times a, which is 16 times c, which is 9. Well, in 0 squared, it's 0 minus me times 16 times 9. That's going to give us negative 576. 0 minus 576 is going to be negative 576, which is much less than 0. So that means we're not gonna have any real number zeros. No real number zeros. What about our second example here? Well, in the second example, we have negative 2x squared plus 7x, but we don't have a c. Well, that's okay, because we got the a, which is negative 2. We got b, which is 7, and then c in this case is going to be 0. So let's determine the discriminant. So 7 squared minus 4 times a is going to negative 2 times c, which is 0. Well, 7 squared is 49 minus Well, the whole thing here is going to be 0 because of that 0 over the end. So this is equal to 49. And since 49 is greater than 0, that means we're going to have 2 real number zeros. Yay! No, 2 is annoying. Oh, okay. Or 2 x-intercepts. Yay! No, 2 is annoying. How dare you? How dare you betray me, X?